Hello friends, welcome to UGC EPG Pathshala. I am Atika Tajdar from the Department of Geography, Jamia Millia Islamia. Today we will discuss about water pollution. The objectives: define water pollution and its different parameters, list the major type of water pollutants, their sources and effects, distinguish between natural and man-made pollutants, state methods for the prevention of water pollution, know necessary legislative measures for prevention of water pollution in the country. Introduction is: water is essential for the existence of all life forms. The major part of water on earth is marine water, which cannot be used without processing by human beings. The only available fresh water which could be used for drinking purposes arises from the groundwater, lakes and streams, etc. The percent volume of it, however, is sufficient to cater the need of the living beings, provided it would have been of high quality. Water quality is important in our lives because it is essential to support physiological activities of any biological cell. In addition to household uses, water is vital for agriculture, industry, fishery and tourism, etc. Increasing pollution, urbanization and industrialization has led to the decreased availability of water. The quality of water used is also being deteriorated as it is getting more and more polluted. A large amount of water is discharged back after domestic and industrial usage. This is contaminated with the domestic waste and industrial effluents. When this contamination reaches beyond certain allowed concentrations, it is called pollution, and the contaminants are called the pollutants. Water pollution may be defined as the contamination of streams, lakes, seas, underground water or ocean by substances which are harmful for living beings. Water pollution may be also defined as any impairment in its native characteristics by addition of anthropogenic contaminants to the extent that it either cannot serve to human for drinking purposes and or to support the biotic communities such as fish. All water pollution affects organisms and plants that live in these water bodies, and in almost all cases the effect is damaging not only to the individual species and pollutions but also to the natural biological communities. It occurs when pollutants are discharged directly or indirectly into water bodies without adequate treatment to remove harmful constituents. Water may be called polluted when the following parameter is stated below reach beyond a specified concentration in water. First one is physical parameters. Color, odor, turbidity, taste, temperature and electrical conductivity constitute the physical parameters and a good indicator of contamination. For example, color, turbidity, etc. The second one is chemical parameters. These include the amount of carbonates, sulfates, chlorides, fluorides, nitrates and metal ions. These chemicals form the total dissolved solid present in water. The third one is biological parameters. These biological parameters include matter like algae, fungi, viruses, protozoa and bacteria. The life form present in water are affected to a good extent by the presence of pollutants. The pollutants in water may cause a reduction in the pollution of both lower and higher plant and animal lives. Thus, the biological parameters give an indirect indication of the amount of pollution in water. Sources of water pollution. Water pollution occur in many forms, from a wide range of sources. Agriculture may contribute to water pollution from feedlots, pastures and croplands. Mining, petroleum, drilling and landfills may also be major sources of water pollution. Other water pollution sources related to humans are sanitary sewers, storm sewers, industry and construction. According to Environment Protection Agency (EPA), more than 50% of the water pollution of streams and rivers occur due to leaching and mixing of chemical from the agricultural practices. The next highest sources was municipal sources, about 12%. Groundwater contamination is from several sources. USGS Circular 1998 says, including agricultural activities, storage tank leakage, industrial waste, sewer and septic leakage, leaching from landfills, mining and many other sources. The surface water pollution has a number of sources and can be categorized into following two: point and non-point sources, and the second one is natural and anthropogenic sources. Let us discuss about point and non-point sources. The well-defined sources that emit pollutants or effluents directly into different water bodies of fresh water are called point sources. Domestic and industrial waste are examples of this type. On the other hand, the non-point sources of water pollution are scattered or spread over large areas. The type of sources deliver pollutants indirectly through environmental changes and account of majority of the contaminants in streams and lakes. For example, the contaminated water that run off from agriculture farms, construction sites and abandoned mines etc. enters a stream. The second one is natural and anthropogenic sources. An increase in the concentration of natural occurring substances is also termed pollution. The sources of such an increase are called natural sources. Siltation, which includes soil, sand and mineral particle, is one such natural source. On the other hand, the human activities that result into the pollution of water are called anthropogenic or man-made sources of water pollution. For example, domestic sewage and wastewater, industrial and agricultural waste that goes into the rivers, lakes, streams and seas are anthropogenic sources. Let us discuss about the major pollutants. The various types of pollutants arising out of the aforesaid sources can be broadly put under the following types: sewage pollutants, which is domestic and municipal waste. The sewage contains garbage, soaps, detergents, waste, food and human excreta and in the single largest sources of water pollution. Pathogenic microorganisms enter the water system through sewage, making it infected. Other ingredients which enter the various water bodies are the plant nutrients, example nitrates and phosphates. They support growth of algae, commonly called algal bloom, blue-green species. According to the UK government's Department for the Environment, Food and Rural Affairs DEFRA, the sewage of Britain collects around 11 million litres of wastewater every day. Some of it is still pumped untreated into the sea through long pipes. Sewage disposal affects people's immediate environments and lead to water-related illness such as diarrhea that killed 5,25,000 children under 5 each year. Industrial pollutants. Many industries located near rivers or freshwater streams are responsible for discharging their untreated effluents into rivers like highly toxic heavy metals such as chromium, arsenic, lead, mercury, etc. Along with the hazardous organic and inorganic waste, example acid, alkalis, cyanides, chlorides, etc. River Ganga receives waste from textile, sugar, paper and pulp mills, tanneries, rubbers and pesticides industries. Most of these pollutants are resistant to break down the microorganism, therefore damage the growth of crops. Factory manufacturing plastic, caustic soda and some fungicides and pesticides release mercury, a heavy metal, along with other effluents in nearby water body. Mercury enters the food chain through bacteria, algae, fish and finally into the human body. The toxicity of mercury became evident by the Minamata Bay tragedy in Japan during the period 1953-60. Fish died due to mercury consumption and those who ate fish were affected by mercury poisoning and quite a few died. Each year, the world generates perhaps 5 to 10 billion tons of industrial waste, much of which is pumped untreated into rivers, oceans and other waterways. In the United States alone, around 400,000 factories take clean water from rivers and many pump polluted water back in their place. Third one is agricultural waste. Manure, fertilizers, pesticides, waste from farms, slaughterhouse, poultry farms, salts and silt are drained as runoff from agricultural lands. The water body receiving large quantities of fertilizers or manures become rich in nutrients which led to eutrophication and consequent depletion of dissolved oxygen. Consumption of water rich in nitrate is bad for human health, especially for small children. Radioactive wastes. People view radioactive waste with great alarm, and for good reason. At high enough concentration, it can kill. In lower concentration, it can cause cancer and other illnesses. Radionuclides found in water are radium and potassium. These isotopes originate from natural sources due to leaching from minerals. Water bodies are also polluted by accidental leakage of waste material from uranium and thorium mines. Nuclear power plants and industries, research laboratories and hospitals which use radioisotopes. Thermal sources. Heat or thermal pollution from factories and power plants cause problems in rivers. By raising the temperature, it reduces the amount of oxygen dissolved in the water, thus also reducing the level of aquatic life that the river can support. Oil spill. Oil tanker spill are the most spectacular form of pollution and the one that catch public attention, but only a fraction of all water pollution happens this way. When we think of ocean pollution, huge black oil slicks often spring to mind, yet these spectacular accidents represent only a tiny fraction of all the pollution entering our oceans. Even considering oil by itself, tanker spills are not as significant as they might seem. Only 12% of the oil that enter the ocean come from tanker accidents. Over 70% of oil pollution at sea come from routine shipping and from the oil people pour down drain on land. However, what makes tanker spills so destructive is the sheer quantity of oil they release at once. The biggest oil spill in recent years occurred when the tanker Exxon Valdez broke up in Prince William Sound in Alaska in 1989. Around 12 million gallons, 44 million liters of oil were released into the pristine wilderness. Estimates of the marine animal killed in the spill vary from approximately 1,000 to 2,800 sea otters and 34,000 to 50,000 seabirds. Several billion salmon and herring eggs are also believed to have been destroyed. Plastics. Plastic is far and away the most common substance that washes up with the waves. Plastic presents a major hazard to seabirds, fish and other marine creatures. About half of the entire world's seabird species are known to have eaten plastic residues. In one of the studies, over 80% of the birds were found to contain plastic residues in the stomachs in North Pacific. Alien species. Most people's ideas of water pollution involve things like sewage, toxic metals or oil slicks, but pollution can be biological as well as chemical. In some part of the world, alien species are a major problem. In the Black Sea, an alien jellyfish called Nemiopsis leedi reduces fish stocks by 90% after arriving in ballast water. Urban areas and roads. A lot of toxic pollution also enter wastewater from highway runoff. Some highway runoff runs away into drains. Others can pollute groundwater or accumulate into the land next to the road, making it increasingly toxic as the years go by. Highways are typically covered with the cocktail of toxic chemicals. Everything from spilled fuel and brake fluids to bits of worn tires and exhaust emissions. It has been estimated that in 1 year, the highway runoff from a single large city leak as much oil into our water environment as a typical tanker spill. Effect of water pollution. Let us discuss about eutrophication. Eutrophication is a process by which a water body slowly becomes rich in plant nutrients such as nitrates and phosphates due to soil erosion and runoff from the surrounding land. Depending on the degree of eutrophication, subsequent negative environmental effects such as anoxia, which is oxygen depletion, and severe reduction in water quality may occur, affecting fish and other animal populations. Biological oxygen demand, which is BOD, the quantity the quality of oxygen used by the microorganism at 27 degrees Celsius and in darkness during 3 days in breakdown organic waste in a water body is called its biological oxygen demand. The greater the amount of organic waste in the water body, the greater is the amount of oxygen required to break it down biologically, and therefore higher is the BOD value of water. The value is a good measure in evaluating the degree of pollution in a water body. The less polluted water shows comparatively low value of BOD. Its value is used as a criterion of managing water pollution of a water body. Bioaccumulation and biomagnification. The increase in concentration of accumulated toxic chemical as one goes higher in the food chain is termed biomagnification. Biomagnification has at times threatened the reproduction and survival of carnivores, secondary consumers, who occupy the highest level of the food chain. A common example is aquatic systems in the accumulation of heavy metals such as mercury in fish. At the start of the chain, mercury is absorbed by algae in the form of methyl-mercury. Fish then eat the algae and absorb the methyl mercury, and since they are absorbing it at a faster rate than it can be excreted, it accumulates in the body of the fish. Further up the food chain, predatory fish and bird then absorb the mercury from the fish they consume, which they accumulate in their bodies, leading to a higher concentration of the mercury in their own body than in the species they have eaten. This is known as biomagnification. Another example, DDT was sprayed in the US to control mosquitoes at the concentration expected to be harmless to non-target organisms like fish and birds. DDT accumulated in the marshes and planktons. Planktons were eaten by fish and the fish had a higher concentration of DDT in its body. Further, when birds ate the fish, they accumulated a still higher concentration. Endocrine disrupting compounds, which is EDCs, are chemicals which can interfere with the normal function of hormones in aquatic animals. They can enter water courses through wastewater, discharges from industry and sewage, and also in agricultural runoff. They are known to impair growth and development in the animals, lead to reproductive abnormalities, and can even cause some species to change sex. Effects of water pollution on human health. Domestic and hospital sewage contain many undesirable pathogenic microorganisms, and its disposal into water without proper treatment may cause outbreak of serious diseases such as amoebiasis, dysentery, typhoid, jaundice, cholera, etc. Metals like lead, zinc, arsenic, copper, mercury and cadmium in industrial wastewater adversely affect human and other animals. Consumption of arsenic polluted water leads to accumulation of arsenic in the body parts like blood, nails and hairs, causing skin lesions, rough skin, dry and thickening of skin, and ultimately skin cancer. Mercury compound in wastewater are converted by bacteria action into extremely toxic methyl mercury, which can cause numbness of limbs, lips and tongue, deafness, blurring of vision and mental derangement. Pollution of water bodies by mercury causes Vidya-mitra, neurological syndrome, disease in humans and dropsy in fishes. Lead causes lead poisoning. The compound of lead cause anemia, headache, loss of muscle power and bluish line around the gum. Water contaminated with cadmium can cause itai disease, also called ouch disease, a painful disease of bones and joint, and cancer of lungs and liver. Control measures. Water pollution control is clearly one of the most critical challenges. Without urgent and properly directed action, world is facing mounting problem of diseases, environmental degradation and economic stagnation. As precious water resources become more and more contaminated, sewage is one of the major causes of waterborne diseases, and therefore the treatment of sewage is one of the important tasks. For a long time, treatment of municipal waste in the form of sewage involved mainly of the removal of suspended solids, oxygen, demanding materials and harmful bacteria. Now, the disposal of the solid residue from sewage has been improved by applying municipal treatment processes. The treatment of this wastewater is carried out in the three stages: primary, secondary and tertiary. During primary treatment, a large percentage of suspended solid and inorganic material is removed from sewage. The secondary stage reduces organic material by accelerating natural biological processes. Tertiary treatment is done when water is to be reused. Here 99% of solids are removed and various chemical processes are used to ensure the water is free from infecting materials. Now, let us explain the three stages of treating sewages. Primary treatment: when the wastewater is to be dumped off into a river or flowing stream, the treatment is carried out by sedimentation, coagulation and filtration. This is known as primary treatment. If the water is required for drinking purposes, it has to undergo further treatment called secondary and tertiary treatment. The following steps are performed to do primary treatment of water is sedimentation. This step is carried out in the large tank especially built for this purpose. The polluted water is allowed to settle so that silt, clay and other matter settle to the bottom, and water is slowly allowed to move out. Fine particles do not settle and are thus required to be removed in the next step. Coagulation: fine particle and colloidal suspension are combined in large particle by the process called coagulation. This step is carried out by the addition of a special chemical called coagulation or flocculants such as potash alum. The large particles either settle to the bottom or are removed in the next step. Filtration: the third step is filtration. Suspended particle, flocculants, bacteria and other organisms are filtered by the passing water through a bed of sand or finely divided coal or through some fibrous material. The total impurities collected in these steps are called sludge. Secondary or biological treatment: if the water is not fit for drinking purposes, that has to undergo further treatment. This is done through secondary or biological treatment. A commonly used method is to allow polluted water to spread over a large bed of stones and gravels so that the growth of different microorganisms needing nutrients and oxygen is encouraged. Over a period of time, a fast moving food chain is set up. It involves the following processes: softening. By this treatment, undesirable cations of calcium and magnesium are removed from hard waters. Either water is treated with lime and soda ash to precipitate Ca2 plus ions as carbonates, or it is passed through cations exchangers. This makes water soft. Aeration: in this process, soft water is exposed to air by forcing air through it to add oxygen and water. This encourages bacterial decomposition of organic matter into harmless products such as carbon dioxide and water. The addition of oxygen reduces carbon dioxide, etc. The water is as yet not fit for drinking purposes. The pathogenic and other microorganisms need to be killed. This is done in the next treatment, which is tertiary treatment. The tertiary treatment is actually disinfecting water. Chlorine is the most commonly used disinfectant used for killing bacteria. However, the chlorine also reacts with traces of organic matter present in water and form undesirable chlorinated hydrocarbons, toxic and potentially carcinogenic. It is therefore desirable to reduce the organic matter in which before passing chlorine gas. Other methods of disinfection are as ultraviolet radiation, ozone gas treatment or reverse osmosis. The other different thing that can tackle the water pollution problem includes management practices. Effective control of urban runoff involve reducing the velocity and flow of storm water as well as reducing pollutant discharges. Local government use a variety of storm water management technique to reduce the effect of urban runoff. These techniques, called best management practices, may focus on water quantity control while other focuses on improving water quality. Education and awareness. Making people aware of the problem is the first step to solving it. Greater public awareness can make a positive difference. International and national law. One of the biggest problems with water pollution is its transboundary nature. Many rivers cross countries while seas span whole continents. Pollution discharged by factories in one country with poor environmental standard can cause problems in neighboring nations, even when they have tougher law and higher standard. Environmental law can make it tougher for people to pollute, but to be really effective, they have to operate across national and international borders. Economics. Most environmental experts agree that the best way to tackle pollution is through something called the polluter pays principle. This means that whoever causes pollution should have to pay to clean it up one way or another. Polluter pay can operate in all kinds of ways. It could also mean that shoppers should have to pay for their plastic grocery bags, as is now common in Ireland, to encourage recycling and minimizing waste. Ultimately, the polluter pay principle is designed to deter people from polluting by making it less expensive for them to behave in an environmentally responsible way. Conclusion: water is essential for the existence of all life forms. In addition to household uses, water is vital for agriculture, industry, fishery and tourism, etc. Increasing population, urbanization and industrialization has led to the decreased availability of water. The quality of water used is also being deteriorated as it is getting more and more polluted. Life is ultimately about choices, and so is pollution. We can live with sewage strewn beaches, dead rivers and fish that are too poisonous to eat. Or we can work together to keep the environment clean so the plants, animals, people who depend on it remain healthy. We can take individual action to help reduce water pollution, for example, by using environmentally friendly detergents, not pouring oil down drains, reducing pesticides and so on. We can take community action too by helping out on beach cleans or litter picks to keep our rivers and seas that little bit cleaner. And we can take action as countries and continents to pass law that will make pollution harder and the world less polluted. Working together, we can make pollution less of a problem and the world a better place. Thank you.